SSL handshake protocol. So this is how the handshake protocol happens. As I told you, it is comprising of 1 byte for the type, 3 bytes for the length, and greater than or equal to 0 bytes for the content. So establishing the connection between two people, it is taken care in 4 different phases. First, establish security capabilities, server authentication and key exchange, client authentication and key exchange, and finally finish the process. With respective to handshake protocol, we have 3 different components. The first one is the type, and the type indicates 1 out of the 10 messages which are indicated here. Hello request, client hello, server hello. These are the contents which can be placed in that for header field called as type. Next we have length. Length indicates the message length, which is of 3 bytes, and the content next field is the content, which indicates the parameters associated with the messages. So this is all about the handshake protocol, and these are the different phases involved during handshake, and it is always the action between the client and the server. It is established in 4 different phases. So what are the different stages are? In first phase, it is establishing security capabilities, which is with respective to protocol version, security algorithms, session IDs, compression methods, and any other requirements will be shared between the client and the server, and the action is initiated by the client. And in the second phase, a response is given from the server with the queries, and they are asking for the server is asking for the certificate of the client. It is also asking for the key exchange algorithm. It is also asking for the certificate request, and after doing this, server says, I'm done, this is the information I require from you, please share that information. In phase 3, in response to the server's queries, client also responds. It had asked for the certificate, so client shares the certificate, also the key exchange algorithm, and whatever was there with respect to the certificate that can be verified. So this is the information given by the client to the server, and their personal informations are shared between the client and the server. And finally, in the last phase, chain cipher specific, that is, should I wait or should I be in the pending state or in the current state. So if in case they are to be in the queue, they will be made to state and wait, it can go into pending state, so which we have already discussed about this. And after this, whether it is active or not active, finishing is the last procedure involved. So with this, the handshake protocol is done. 4 different phases, and finally handshaking is done and the business is established. So the same information which I had told is given here. Logical connection is initiated, version and the bit random bit which has been generated, session ID. These are all the information shared in the first phase. Second, server asks what is the protocol version, what it should be lesser than that of the client. Like this, the information is shared. And next phase 2, server sends the information with respective to the queries put on to the client, and client responds with respective to the queries asked by the server, and whatever was asked for, that is produced by the client to the server. And finally, the finishing process, before finishing, it also says whether you should go into pending state or active state. Next, we have the transport layer security. Just like how we have the SSL layer, we have the transport layer, and it is TLS, transport layer security, abbreviated as. We have few differences. With respect to the differences, we understand what is TLS. SSLs had the major and minor version as 3.0, whereas TLS has 3 and 3. So in SSL it is 3.0, in TLS it is 3.3. SSL uses the MAC algorithm in order to provide authentication. TLS uses HMAC algorithm. We'll understand about this shortly. In SSL, the keys are concatenated, they are just combined, whereas in TLS it is XORed. And TLS uses pseudo-random function to the key. In order to generate the key, pseudo-random function is used in TLS, whereas nothing like that in SSL. You can go along with the Diffie-Hellman algorithm or the RSA algorithm. And TLS also has the alert codes, but here there are no warnings. The codes are fatal, whereas in SSL the codes were fatal and warning. So this is what is the HMAC. In order to have your message authenticated, this is the function which is involved. The hash function is involved with respective to K key, actual some key which has to be considered in order to, not some key, it is a key. So key is XORed with O pad, outer padding. And this is concatenated with the hash value of the key with the XORed inner padding, and these two are in turn concatenated with the whole of this message, and this whole of this content is hashed. So not once, not twice, thrice the hash function is being done to ensure better authentication. So H is the hash function, M is the message, key, K is the key, and iPad is inner padding, which is iPad here means it is 36 in hexadecimal, and OPAD or the outer padding is 5C in hexadecimal. This is done multiple times, which is 64 times. So this is how the HMAC algorithm is given as already discussed. And so what is pseudo random function? So pseudo random function is used to generate the key in the TLS, and it is based on a data expansion function. So here it is considered where the seed is referred to as A of 0, and AI is the current state which is given as HMAC of hash function with respective to secret. So when we look into the diagram, there is a more clarity in understanding how the key is generated. Seed is taken. So initially some value is taken which is A of 0, and it is sent into the HMAC algorithm. So the two inputs for the HMAC algorithm is the secret key and the seed. So these two generate the output, and that output can be considered here as A of 1, which goes to the next stage. Otherwise, that same HMAC which is generating the output is again concatenated with the seed value which was used earlier, and that in turn is given to the HMAC algorithm next time. Twice the HMAC algorithm is implemented, and final outcome is set into this place in the field where key part is placed. Similarly, it goes on with what is the n bits. So you have 2 to the power of something, 8 or 16. So 16 such fields are generated, and that would be the length of the key. Second stage, A1, instead of seed, the input would be A1. A1, and the secret is the algorithm contents. The output is concatenated with the seed and goes to the next stage where a key is field is generated, and this continues. This is how the pseudo random function works, and this is generally asked for 6 marks during your academics. Next, there are alert codes, few alert codes which are fatal. So fatal in the sense any such occurrences are there, the process should be terminated or abandoned. Record overflow whenever it is crossing the size. There is a limitation of 2 to the power of 14 plus 1024. If the size is more than this, this has to be terminated. Unknown CA. So there are so many ATM cards which has been successfully given by so many banks, and there is no proper guarantee about the usage. So in such cases you cannot trust and you cannot proceed, so you have to deny or you have to abandon. Access denied. If you are a legal person, you will never have a problem called as access denied. Only until and unless the card is stolen or card is manipulated, you get this kind of error. So immediately this kind of access denied pops up, the procedure should be terminated. Decode error, whenever the decoding is or decryption is not properly done, it has to be stopped. Protocol version is not matching with that of the client, it has to be stopped. Security is not there, that is whenever handshake fails. So authentication is not claimed between the client and the server properly, then handshake fails, and therefore it has to be terminated. Next, unsupported extension, message sent by client but not acknowledged. So whenever you send an information, it should be acknowledged. Yes, I received. You can please take this information since you had asked. That kind of messages should be supported. If there is no acknowledgement in response, therefore it has to be terminated. Internal error can occur if their protocol is not correct, and again if the decryption is not correct. So this is where we can't verify what is the signature, and decryption is not possible. In this case, you have to terminate the procedure. And what is the comparison with respective to the cipher suites in TLS and SSL? Cipher suites are nothing but the algorithms used for encryption. So key exchange and the symmetric encryption, whatever the algorithms used for key exchange in SSL is the same in TLS also. So the key exchange algorithms are Diffie-Hellman and RSA algorithm. Symmetric encryption means a single key is used during the encryption as well as the decryption, and this process is called as the conventional encryption, where conventional key is used. The same is used even in TLS. No much difference. The differences are there, but it is very much minor. Next, client certificate types. What are the types of the certificate you are asking for? So, TLS, it asks for special type of certificates: RSA sign, DSS sign, RSA fixed DH, DSS fixed DH. So, this is the request asking. So, how do we do the signature authentication using RSA? So, this algorithm has to be used. Are you using? Give me the information about this. Similarly, DSS, RSA fixed DH. So these are all defined in SSL also, and same, nothing much difference. In TLS also it is used, in SSL also it is used. Apart from that, SSL uses some extra algorithms, which is RSA ephemeral DH. So what is this? This means that involves signing the Diffie-Hellman parameters with either RSA or DSS. So this is a combination of RSA algorithm and DH algorithm, Diffie-Hellman. Similarly, you have DSS, digital signature standard, and the Diffie-Hellman algorithm. Like this, the combination of client certificate types are used, and these are the different algorithms. Padding is used. In SSL, the padding is done before encryption, and so that you are matching with that size of the block, cipher block. In TLS, the padding can be any amount. There is no any restriction, but see to it that the final outcome or the final field doesn't exceed beyond 255. So padding is same as that of SSL and TSL, TLS, but the minor difference is it shouldn't exceed beyond 255 bytes. Next we have HTTPS protocol, which is substituted as HTTP plus SSL. So SSL is completely involved in the hypertext transfer protocol, and as a result security is provided. So S indicates as secure, but that secured is in turn not achieved as it is because of the SSL layer. So wherever we have the web browser and web server, this comes into picture, and most of the search engines like Google is not giving us yes. So most of the times when you check into Google, it is only HTTP. Why? Because it is an open source, anybody can view, there is no need of any security for this. So S is not required here. And please remember the port numbers. For HTTP it is 80, for HTTPS it is 443, where it is invoking the SSL. So these are the port numbers, as and when we are using this, these ports gets activated and do their respective jobs. And during when you are using HTTP in your search link, what are all the things which are encrypted? It becomes hidden, no information is leaked out. So your URL is encrypted, contents of the document, contents of the browser, cookies, contents of the HTTP header, all the informations are encrypted, and as a result it is protected. And after protection, next you have to establish connection. So connection is between the TLS client and TLS server. This is done with the handshaking procedure. So to initiate the connection, both of them should identify themselves as what they are by sharing their personal information of the protocol version, about the encryption algorithm, about the keys they are using, and once that is established, connection is done. So how it is done in terms of HTTP level, it is with respect to the TCP layer and the SSL layer session, and finally the connection is established. After the connection is established, the business is done, and next comes the closure. Connection should be disconnected. If it is there, unnecessarily the traffic is involved and it has to be disconnected. So how it is disconnected? Once you are doing your close. So when you close, any related information also is being terminated. So at the peer level, right from the TLS, which is just above the session, just in the session layer, the transport layer, all the layers, protocols which are used are terminated or closed, and the connection is done. Connection closure is done. The connection is disconnected after the job is done. And these are the various applications of HTTP. It is used to protect the network. Therefore, routers and DNS are protected, and attacks like passive and active in the network level are avoided. So where exactly the types of errors come? In the cafe where you are using the wireless, network is not provided, so then in that case HTTPS, if you are using, it is protected. Similarly, accessing the internet in the hotels, which is untrusted, there also there is a procedure of getting your network hacked, therefore HTTP is used. Most of the time HTTPS is not used in web traffic because it slows down the process. So security issues, when it is checking for more and more secure information, it consumes more time, therefore it is late. And this is how the icon looks. So HTTPS in Stanford, it is pertaining to respective university, so it has to be secured. So ultimately the goal here is to protect the network. So these were the higher layer protocols: Handshake Protocol, HTTPS, Alert, and Handshake. Next we have the last protocol, which is SSH, which is basically meant for providing the security to the network. So it is a protocol which is simple, and two versions were given. One is the SSH1 and the other one is the latest one is SSH2. So this is basically providing security for remote logons. So earlier it was Telnet which was providing, now it has been replaced with SSH. So the intention of coming up with SSH was to provide security for remote logons, and this also is based on the client server capability, and it is normally used in file transfers and emails. And the updated version is SSH2. Whatever the flaws were involved in the first one, that is been slightly updated. And again, this is also for the client and server applications, and it is used for remote login, not only remote logon. Earlier it is still meant for that. And there's one more thing called as tunneling. So tunneling is movement of data from one network to another network. When you find from one network to another network the path is hacked, then the alternate path is chosen, which is tunneled, and then the safe transfer of information is done. So how is the process of SSH evolved? It is from the University of Finland. In the year 1995 they came up with this protocol called as SSH, which is Internet Engineering Task Force draft, because that is something which is globally accepted, and it was finally released as www.ssh.com. And later it also took the second version, which is SSH2. So from Helsinki University this is evolved. And what is secure shell? It is a powerful, convenient approach of protecting communications on a computer network. Not only the network, the communication and transmission is also protected. What are the features of this? So this involves strong end-to-end encryption. That means the data is protected, therefore you should have a best of the best algorithm, which involves DES algorithm, IDEA algorithm, blowfish, etc. And it also supports integrity. So cyclic redundancy check. Any errors are there, it is predominantly checked again and again, and the data is not modified and it retains its originality. Authentication, so where it is sent from the origin, that is also checked using the right type of the host key via the passwords of the public key. Authorization, it reach to the right person, so and the right person should have the control on it. So this is also with respect to the server, the control is taken, and possibility of hacker involving is avoided. Next, forwarding. So for this forwarding is, it is encapsulating along with the work of its own work, it is also doing some other work. So encapsulating another TCP based service such as Telnet within an SSH session. So not only one work job it is doing multiple jobs. These are the features of SSH algorithm. And this is the protocol stack. So when you see here, you have the network layer with IP protocol, internet protocol. Next you have the transport layer with TCP protocol, and next we have the SSH or the session layer, where we have varieties of protocols, and here we are focusing on SSH. Therefore it is three different protocols which are used. Normally in SSH protocol. So focus on SSH transport layer protocol, SSH user authentication protocol, SSH connection protocol. So whatever the work it is doing, it is prefixed with SSH. So provides server authentication, confidentiality and integrity. So yes, what is meant for protecting your network, that is supported by SSH transport layer protocol. It may optionally also provide compression. So it can also do the effect of compression. And this is SSH user authentication protocol. So authenticates the client side user to the server. Client is safe. You can go ahead, proceed with your conversation or any transactions. SSH connection protocol multiplexes the encrypted tunnel into several logical connections. So basically connection is establishing between one to one, but here it not only supports one to one, it also supports many to one. So multiplexing capability is there in this SSH protocol stack. SSH connection protocol. So these are the different protocols. So please remember about SSH transport layer protocol, SSH user authentication protocol, SSH connection protocol. So what is the purpose of these protocols? Number one, transport layer, as we already told, provides security authentication, data confidentiality and integrity along with forward secrecy. That is a key, if it is used, doesn't matter, the key is still safe. Authentication with respect to the server, telling about the client's status. Next you have the connection protocol, which does the multiplexing operation.